use it in your Algebra 1 class very much. So got to think back to when you learned some geometry terms. We're going to classify angles today. So how many of you have heard of a right angle? Okay, hands down. Acute angle, obtuse angle. All right, so those are some of the things we're talking about today. So some of this is going to be very simple. You've learned it before, and some of it will be new things that you haven't learned before. A big thing today is still like what was important last class, and that is notation and naming things correctly. So we talked about naming segments and rays and lines and planes and naming those correctly. We're going to be doing the same thing today with angles. All right, so one of the things that they're going to talk about when they're talking about angles, sometimes in the word problems, is a transit. And I just wanted to throw that up there to explain what a transit was in case that's in a word problem. A transit is just a tool that's used in surveying to measure angles. You may have seen, looks kind of like a tripod sitting alongside the road and people are out in the field and it basically just shoots out lasers and helps them get measurements so that they can determine what those angles are, what those distances are for surveying. So if you see the word transit, that's what they're talking about. Okay, first vocab word today is angle. An angle is a figure that is formed by two rays. I will be super picky about that. When you draw an angle, it should not look like the blue angle I have on the board. What is wrong with that? Okay, I need my arrows. These are two segments. It's not formed by two segments, it's formed by two rays. So make sure you have arrows on the ends. Those rays are also called the sides of the angle. So if they ask you to name the sides, if they gave you some points, then you could name the sides of the angle. What is one ray in that picture? AB, very good. Always have to start with the vertex. And what is the other ray? AC. Good job. And make sure you're putting those arrows above it. So angles are made by two rays. They have a common endpoint. That common endpoint is called the vertex. So A would be your vertex. You don't say vertexes, that's not the correct plural form. Plural form is vertices. Okay, so if we have more than one vertex, we have vertices. There are several ways you can name an angle. Some of them can be used all the time, and some of them can only be used some of the time. So I'm going to show you the different ways that you can name an angle. The first way you can name an angle is by its vertex. So for example, make this a little bigger up here. What would I name this angle if I'm naming it by its vertex? What is its vertex? Talk to me. A. So when you name an angle, you have to use an angle symbol. So I could call this angle A. There is a difference between an angle symbol and a less than symbol. What do you notice is the difference? Kind of. Anybody else? What do you notice is the difference? So the less than looks like it's wider, the angle doesn't. The angle's flat on the bottom. Do you see how it goes flat, whereas the less than symbol is more like an open mouth? So I'm not picky about that, but when I had a teacher or professor in college, super picky, that I had to make sure my angles were flat on the bottom, not a less than symbol. So just be careful when you're writing it. So one way you can name an angle is by its vertex. Another way you can name an angle is if they have a number written inside the angle. It's not giving you the measure of the angle, but it's just a way to name it. So we could also call this angle 1 because there's a 1 inside the angle. Okay, so a second way that you can name it is by a number. The third way you can name it is by using 3 points on your angle. But when you do it that way, this is the third way, by a point on each ray and the vertex. When you name it with 3 letters, the middle letter has to be the vertex. So you could name this angle BAC. If you name it that way, though, the middle letter has to be your vertex. Or you could also name it angle C. A, B. So it doesn't matter as long as the middle letter is your vertex. You can either start with this ray or this ray. Okay, these two, naming it by the vertex and naming it with a number, only work if there's only one angle in the picture. If there's more than one angle, you cannot use those two options. So for example, how many angles are now in my picture? 3. I have an angle here, which I could call angle 1. I have an angle here, angle 2, and then what's the other angle? The entire great big angle. So this whole thing would also be an angle. If I say angle A, do you have any idea which angle I'm talking about? Not if you say angle A, because they all have vertex A. So if you're going to name your angle, you can use a number as long as it's been identified as which angle in the picture. So since they all have a number, I could call this angle 1, I could call this angle 2. But you cannot name it by its vertex if there's more than one angle in the picture. So you could call, if they give you another point, you then have to use those 3 letters. So you could say either angle 1, or how else could we name angle 1? Use your letters. Careful, remember your middle letter has to be your vertex. Angle BAD. Is that what you said? I'm so sorry. Okay, so we can name it angle BAD. What's another way we could name it? Angle DAB, angle DAB. Okay, look at angle 2. We could name this angle 2 because it's specific to just this part of the angle. How else could we name angle 2? Angle CAD. Somebody else? How else could we name that angle? Angle DAC. Notice I'm putting an angle symbol in front of every one of them when I'm naming an angle. Okay? We already talked about how we could name the big angle BAC or CAB. But you cannot name it angle A unless it's the only angle in the picture. So if you look at your notes, you'll see a picture of an angle here and all the different ways you could name that angle. You could name it angle R because there's only one angle. You could name it angle 1. You could name it angle SRT or angle TRS. Notice again that the middle letter is your vertex when you have 3 letters. Okay? Questions about naming an angle? So good question. So first of all, let me tell you that you're not allowed to add anything to your picture. So if they don't number it, you can't use numbers to name it. You'll have to name it by whatever's in your picture. But if they were talking about this great big angle, they will typically put a big arc, that's one continuous curve, to show you that they're referring to the big angle. And then they'll just write a number somewhere out to the side of that. So it could be here or it could be up here, but if they put it right by the curve, then you know that they're referring to the entire angle. They don't do that very often. Most of the time they will label points on it and you'll use 3 letters if it's the big angle. Okay, good question though. All right, when you think of interior, what do you think of? Inside, right? Inside. So interior of an angle are the set of all points between the sides of the angle. All the points that are between the sides, that's your interior. When you think of exterior, what do you think of? Outside. So the exterior is the set of all points outside the angle. So that's going to be everything out here. Now, points S, R, and T are not interior or exterior. They are on the angle. So S would be a point on the angle. T would be on the angle. R would be on the angle. Does that make sense? Okay. All right, so I want you to go ahead. I'm going to call on you so I can learn your names better. I've been studying my pictures, but not long enough, obviously. So this says to write the different ways you can name the angles in the diagram. So I'm going to pick on first Jacob. Name any angle that you see in this picture. Say it again, I'm sorry. Okay, so remember to put your angle symbol, angle 1. All right, so the next person I call on, I want you to name angle 1 a different way. So let's go with Jackson Smith. Do you go by Jack or Jackson? Jack. Let me fix that on my picture sheet. I fixed it on my other thing, but I didn't fix it on here. Sorry, Jack. Okay, Jack. Very good. Oh, wait. There we go. So I could name that same angle, angle QTR. Can I get a volunteer to name that same angle another way? Very good, angle RTQ. Okay, next person I call on, I want you to pick a different angle in the picture. Let's go with Barrett. Angle 2. All right, next person needs to name angle 2 a different way. Let's go with Faith. Angle RTS. And naming that same angle, can I get a volunteer to name it the last way? Carlos. Very good, angle STR. And then there's one angle in the picture that we haven't named yet. What angle is that? Go for it, Barrett. Very good. The great big angle, angle STQ. And what would be a different way we could name that? Angle QTS. Can we name any of these angles angle T? No, because we wouldn't know which one we're talking about. Any questions on how to name an angle? All right. Super important. You may think, oh my goodness, that's too basic and simple, but it is going to cost you points throughout the year if you don't get that notation down correct. So super important. Okay, when you measure an angle, there are different ways to measure an angle, just like there are to measure a line segment. If you get a ruler, what are the measurements on a ruler? Inches or centimeters. So there's two different ways you can measure a line segment if you have a ruler. The same idea if you're measuring an angle. There are different ways you can measure an angle. You can either measure them in degrees or you can measure them in radians. We aren't going to talk about radians unless we have time, and that'll be at the end of the year. If you take pre-cal, then you'll learn in pre-cal the difference between a radian and a degree, and you'll talk about measuring them in both measurements. But for our purposes, we're going to focus on what you're going to be held accountable for on the geometry end of course test, and that is degrees. We're going to measure all of our angles. So the measure of our angle is usually given in degrees. And we're going to measure ours in degrees, so we need to understand what a degree is. So if you think about a circle, how many degrees are in a circle? 360 degrees. So if I say I have 1 degree, that means if I were to take a circle and divide it into 360 tiny little pieces. So imagine that there's 360 of those. One little angle there would be a degree. Does that make sense? It is 1/360th of a circle. That is what a degree is. Okay, so it's really small. All right. So again, I asked you if you already knew these words and you've heard them before: acute, right, obtuse, and straight. These are vocabulary words. So you will need to know them for your very big first vocab test, which is not this week, so no worries. But when it comes, these will be words that are on your vocab test. So acute. How many degrees are in an acute angle? Could be bigger than 89. Okay, it has to be less than 90. It could be 89.9, 89.99, right? Could be a little bit more than 89. But the definition you need to know is it is greater than 0 and less than 90. You will not have a negative angle measure. If you get a negative angle measure, you've done something wrong, okay? So it's between 0 and 90 degrees. A right angle is exactly what? 90, and notice the little right angle box. That's how you can denote in a picture that it is 90 degrees. So anytime you see that little right angle box, think that's a 90-degree angle. Obtuse is going to be bigger than 90, but it's going to be less than 180. So again, it could be 179.9999, but less than 180. So greater than 90, less than 180. And then a straight angle looks just like a straight line, but it's how many degrees? 180. It's exactly 180. And remember that this picture actually can mean 3 things. It could mean it's a straight angle, it could be just a straight line, or it could be 2 opposite rays. Those are all in this picture. Would you agree? Okay, so it just depends on what that is in context within your problem. All right, so we're going to talk about protractors and using our protractors. Before we use our protractor, we're going to look at this picture in our notes and try to answer these 2 questions. You want to find the measure of each angle and then classify it as acute, right, or obtuse. So 2 parts to the question. Find the measure, classify it by one of those names. Find the measure, classify it by one of those names. So go ahead, you and your partner, looking at your picture. Okay, so first of all, we'll go over these in just a second, but grab your protractor that's on your desk. I gave you 2 if you have a partner, so pass one over to your partner. Not save one for myself. Let me grab my, actually, no, mine does. Yes, it does. Okay, so when you look at your protractor, couple of things to remind you about a protractor when you're reading it. When you're trying to measure an angle, there's 2 different numbers on your protractor. So when you're reading, you have to decide, are you reading from here on the left and going to the right to make your decision? Or are you reading from the right and going to the left to make your decision? If you're reading from here, remember that you start at 0. So you would be looking at the numbers on the top. If you're reading from here and going around to measure your angle, then you're starting at 0 and you'd be reading the numbers on the bottom. Very important that you're careful about which number you're looking at on your protractor. So we're gonna actually draw an angle in a minute with our protractor, but for right now, let's go back up to here. You're trying to find angle WXV. So take your pencil and trace. Start at W, go to X, and then V. That's determining which angle you're talking about. WXV. When you look at that angle and you read your protractor, am I going to start here and go 10, 20, 30? Or am I going to start here and go 180, 170, 160, 150? Start at 0. So what is the measure of this angle? 30 degrees. So my answer for part A would be 30 degrees. You must put a degree symbol because remember, angles can be measured in different ways. So you have to put your units. And what is a 30-degree angle? Acute. All right, questions on the first one. Let's go to the second one, ZXW. So again, put your pencil on Z, then go to X, then go to W. So now we're talking about this angle. But the problem with this picture is that we're trying to read the measure of this angle, but it doesn't start at 0, right? So when we look for our answer here, we can't just come over to where this crosses and say, okay, this is a 130-degree angle because we didn't start at 0. You're going to have to come down here and start at 0. So again, you're reading these bottom numbers all the way around. It looks like 130, but we didn't. Sorry, just a second, guys. I didn't hear what he said just there. Hopefully it's here. Nope. Okay, so we have to take that 130, and what do we have to do to get the measure of our angle? subtract the angle that we had here that we didn't want in our picture. So we take away 30, so what's the measure of the angle that we're actually looking at? 100 degrees. And what is that classified as? Obtuse. Okay, take your protractor. You're going to draw an angle now. I want you to draw a 75-degree angle on your paper. So when you do that with your protractor, just a few reminders, and you can do this with me to practice. So maybe turn your notes over on the back somewhere. Find room to draw an angle. First thing you're going to want to do is draw a ray, because angles are made up of two rays. So I'm just going to draw a ray on my paper to start with. Once you have your ray drawn, remember you're going to take your little circle that's in the middle of your protractor and line that up with your vertex. So you want your circle and your vertex to line up, and you want the 0 on your protractor to line up with your ray. So circle and vertex, 0 and ray. Everybody with me there? Then you're just going to read from 0 up to, what did I say? 75? So go to 75, and let's make an angle. So go up to 75. I would go to 75 and just make a mark on your paper at 75 degrees. Keeping it at 0, circle at the center, go to 75, make a mark, and then you can just turn your protractor and connect your vertex to your mark with your straight edge. And if you did that correctly, you have a 75-degree angle drawn. Questions on how to use your protractor or read your protractor? Okay, remember this was one of the tools that were listed on your supply list. If you have not purchased a protractor, it is highly likely that you're going to have a question on your homework that requires one. So your options are to either come in before school in the morning and do that problem before it's due on Thursday, or go and get yourself a protractor. Okay, but you do need to do those problems. So you might look ahead if you don't have a protractor that you have at home to use, and see which problems are going to ask me to draw an angle, and then make sure you get those done while you're at school, or show up a little bit early before school. All right, moving on. Congruent angles. Just like last class period, we had congruent segments. We're also going to have congruent angles. What did congruent mean again? Equal. Okay, congruent means they have equal measure. Remember that our symbol for congruent is an equal sign with a little squiggly above it. Everybody with me? So if two angles are congruent, then they have the same measure. I'm going to remind you about that picky notation. Shapes are congruent. So you can say angle ABC is congruent to angle DEF. You can say that line segments are congruent. But if you're talking about their measurement, 30 degrees, 100 degrees, their measurements are going to be equal. What is the difference between this statement and this statement? Okay, notice the little m's. If you're giving me the measure, you have to put a little m in front of it. So if you're saying the measure of the angle is 30 degrees, when you write your answer, you'll put the measure of angle ABC equals, and then you'll put your answer 30 degrees. I will be picky that you have a little m, okay? So if you're giving me the measure, you should have a little m. What else is different between this statement and this statement? Besides a little m. Okay, one of them is congruent, one of them is equal. Remember that the shapes are congruent. So if you're just naming the angles, those can be congruent. If you're talking about their measurements, those are numbers, and numbers are equal, not congruent. Okay, just like with segments, we had little marks that would indicate if they were congruent in the picture. What did we call those marks? If they were line segments. Do you remember? They were called tick marks. Tick marks, if they're line segments, they're called arc marks if they're angles. They'll use different numbers of markings to indicate whether they are or are not congruent. So if I have a picture up here on the board, a couple of things. This is really important. Students get confused on some of the pictures sometimes. So let's say I have these two angles up here, this big angle divided into two. If they want to tell me that this first angle is congruent to the second angle, then they will stagger the marks. They may put 1 and 1, they may put 2 and 2. But if they put the same number of arc marks, that means they're congruent. Does that make sense? If they're talking about the measure of the whole angle, then they'll make one solid mark. That means they're telling you that the whole angle is whatever they put there. So if you see something like this, 80 degrees, but it's written right here, it doesn't mean that this small angle here is 80 degrees. It means the whole angle is 80 degrees. They can't put it right in the middle because then it's going to be written over the ray, and then that's going to be confusing because it's hard to read. So they'll shift it to one side or the other, but if it's a solid curve, they're talking about the big angle. If they're saying they're congruent, they'll stagger them, so it won't be one solid curve. Are we clear? Okay. This goes back to the same thing that we learned last class period. We learned the segment addition postulate. Remind me, what did the segment addition postulate say, just kind of in non-mathy terms? If you had a line segment, what did it say about it? We talked about it in class. I'm worried about you guys. Segment addition postulate, what did it say? You had to use it on your homework. If you haven't done your homework yet, then you're going to have a lot more to do tonight. This was from 1-2, so it wasn't the stuff that was due today. If we had a line segment, oops, I'll call that B, A, C. What did the segment addition postulate say about this line segment? Very good, Chris. It said part plus part equals the whole. Okay, we have another addition postulate, but today it's called the angle addition postulate, and it says the same thing, it's just with angles. So once again, it's kind of common sense, but it's going to say part of the angle, so notice we have this part here, RQS, plus the other part of the angle, SQP, should equal the great big angle, RQP. So the measure of the little angle plus the measure of the other little angle should equal the measure of the whole angle. Part plus part equals whole. Best advice when you're working on your homework, because some of these problems are going to get a little harder. Draw a picture. Every student that has sent me a text message over the weekend in my other classes that have had questions, the first thing I've asked them is, have you drawn a picture? Did you label your picture? And if they still had trouble, then I would say, send me what you have drawn, and we would look and see if what they've done is correct. So if you haven't drawn a picture, that's going to be the first thing I ask you. Draw yourself a picture. Okay, so for example, we'll start off pretty easy with numbers here. You with me, Jackson? Okay. Where are your notes at? You can keep them out so you can look at them. So look at your picture. Let's label our picture. The measure of angle DEG is 115 degrees. Is that one of the parts or is that the whole? Okay, so remember DEG means start at D, go to E, go to G. So that means they're giving you the whole angle is 115 degrees. Label your picture. Okay, the next thing they tell you is DEF is 48 degrees. Is that the top half or is that the bottom part? Top, DEF. So you go from D to E to F, label your picture, 48 degrees. Okay, they want you to find the measure of angle FEG. So that's asking you to find F to E to G, this other part, right? So what do you think we do? If I add, that would be saying that this little part would be the whole thing plus this part. Okay? Exactly. So we need to subtract. If you're not sure what to do, write out your angle addition postulate. Part plus part equals whole. So you could say the measure of this little angle, DEF, plus the measure of the other little angle, FEG, should equal the great big angle, measure of angle DEG. And then plug in your numbers. So DEF, according to the problem, was what? 48. plus, we're looking for FEG, so we don't know the measure of that angle yet, equals, and what was the great big angle DEG? 115. Then you've got an algebra equation, and you can say, okay, I need to get EFG, or FEG, sorry, all by itself. So to do that, I'm going to subtract 48 from both sides. And what is the measure of angle FEG? I don't think it's 77. 67, okay? So we have to borrow from this to subtract. 15 minus 8 is 7, 10 minus 4 is 6. So 67 degrees. Also, don't forget, you guys can grab a calculator when you come in first thing in the mornings. Turn your homework in, grab a calculator so that you'll have that at your desk every day. Okay, let's try another one. Before we get to this example, I want you to add this one to your notes. So write this down. Okay. What would I do if I wanted to find the value of x or find any of those missing angle measures? Using what we just learned, angle addition postulate. What could I write down? Oops, I need a letter here, don't I? Sorry. How about D? So measure of angle ABD, Chris said. We can do that in a minute. Let's set up our equation first. So you are right that this angle is equal to 2x plus 3. Okay, raise your hand if you understand what Chris just wrote down. Okay, I got a few of you. Part plus part should equal the whole. Okay, so part of the angle plus part of the angle should equal the whole angle. So he said ABD, the part, plus DBC, the other part, should equal the whole big angle ABC. Now we can plug in our expressions. So Sydney, what are we going to plug in for ABD? 2x plus 3. Caleb, what am I going to plug in for DBC? 5x plus 4 equals, and Nathan, what am I going to plug in for ABC? 10x plus 19. And now we have an algebraic equation that we can solve. Okay? Help me out. What do we want to do on the left here to simplify this? What does this become? 7x plus 7. 5x plus 2x is 7x. 3 plus 4 is 7. Set that equal to 10x plus 19. Okay? Jackson, what do you want to do from here? Minus 7. Okay, so minus 7 on both sides. So I have 7x equals 10x plus 12. Now what? Subtract the 10x. When I subtract the 10x, what is 7x minus 10x? Negative 3x equals, and then I have 12 on the right. So what would I do from there? Divide by negative 3. And what does that make x? Negative 4. Now, I made this problem up off the top of my head. You can get a negative value for x, but what can you not have a negative value for? Can you have a negative angle measure? No. So if I were to plug in -4 and it gave me a negative angle measure, then it would not be correct. So I made a bad problem. This would not really be how it will work out on your homework. You'll end up with probably a positive value for x, which will then in turn give you a positive angle measure. Unless this number that you're adding is really large, because if I have a negative number here, but this is really large, it'll still give me a positive angle measure. So, but do you get the idea of part plus part equals whole? Okay. Moving on, just like last class period, we had a point that split a line segment into 2 equal parts. What was the name of the point that splits a line segment into 2 equal parts? Bisect is what it's doing, but what's the name of the point? Somebody say it. What is the name of the point that splits a line segment into 2 congruent parts? Midpoint, thank you very much. So you need to know those words, guys. Midpoint splits a line segment into 2 congruent parts. The same idea of a midpoint or bisecting is the angle bisector. An angle bisector is simply a ray that divides an angle into 2 congruent angles. So if you have a picture of an angle, a big angle here, LJM, then JK is the ray that is bisecting the angle, meaning this ray is now splitting my angle into 2 congruent parts. If you see that word bisects, the very first thing you should do is go to your picture and put some arc marks on it. This little part is now congruent to this little part. You now know that they should have equal measures. Okay? So angle bisector is just like a midpoint bisects a line segment, an angle bisector bisects an angle. That leads us to our last kind of problem that's in your notes here. Notice the very first thing it says is KM bisects angle JKL. So what's the very first thing we should do to our picture? Arc marks. Go to your picture. KM, this ray, is splitting this angle, JKL, into 2 congruent parts. So that means now this part and this part are going to be congruent. So you need to mark them with the same number of arc marks. You can do 1 and 1, 2 and 2, it doesn't matter. Okay, so what does that mean about their measurements? They're the same. Okay, keep that in mind. So now you're going to label your picture with your information. Angle JKM measures 4x plus 6. So go to your picture, JKM, this part here should be 4x plus 6. Next thing it tells you is MKL is 7x minus 12. So go to MKL, that's this angle, that's 7x minus 12. Notice the difference between this problem and the one on the whiteboard. They gave us the part and the part. What did they not give us on this one? The whole. You cannot do angle addition postulate, part plus part equals whole, unless you know the part, and the whole. But just like we did with segments last class period, if we had a midpoint, that meant the 2 segments were the same, so we set them equal to each other. If we have an angle bisector, that means the 2 angles are the same, so we can set them equal to each other. So what would my equation be that I could write down? Very good, Carlos. 4x plus 6 is equal to 7x minus 12. Is this making sense? Questions? Okay, and then now we're just back to algebra. We have to solve for x. So let's go with Jacob. What do you want to do here to solve for x? Add 6. Ooh, we already got an add 6. There you go. Subtract 6. So now I have 4x equals 7x minus 18. Okay, let's go with, is it Tori or Victoria? Tori, that's what I thought. I didn't change it on this paper though. Is that T-O-R-I? Thank you, Tori. What do you want to do next, Tori? Subtract the 7x. So now that gives us what on the left? Negative 3x equals, though, negative 18. So in this case, it's going to work out nicely because what do we need to do next? Divide by negative 3. And what is a negative divided by a negative? Positive. So we have x equals what? 6. Is that our answer? No, always read those directions. It says to plug it back in and find the measure of JKM. JKM is this little piece here. So that means we're just going to plug it back into the 4x plus 6 part. That's equal to the measure of angle JKM. Don't forget those little m's. So plug your 6 in for x. 4 times 6 plus 6. What's 4 times 6? 24 plus 6? 30. So we're going to say the measure of angle JKM is equal to 30 what? Degrees. Don't forget your degree symbol. Questions? All right, that's the end of 1-3. Let's move on to 1-4. At this point, I want to make sure you are very clear about homework. The homework assignment number 2 was over sections 1-2 and 1-3. If you already did the first page, that was over 1-2. So now the second page on that homework assignment you have will be over what we just did 1-3. So you have everything you need to know now to finish that homework, and that homework is due when? Thursday. Okay, we're going to go ahead and do 1-4. I'm going to give you another homework slip, but it is not due on Thursday. Okay, so you have one homework assignment number 2 that's due Thursday. This one won't be due until the following Monday. All right, and then we're going to get caught up on Monday, and I'll stop giving you different slips every time. It'll be what you should have. But we got a little behind on that first day of school, just with everything. Okay, so this section is basically just some vocabulary that you should have learned again back in middle school. You may remember it, you may not. It is really just these definitions. Okay, so we're going to go through them and look at some examples. The first one is adjacent angles. When you think of adjacent, what do you think of? What does it mean to be adjacent to something? Next to each other, okay? So adjacent angles are simply 2 angles that are going to be right next to each other, but they have to have a couple characteristics. First of all, they have to be in the same plane, and that just means on the same sheet of paper or on the same wall, same tabletop, same flat surface. They have to be in the same plane. They have to have a common vertex. Be very careful. Sometimes they'll trick you. These 2 angles in this picture up here, angles 1 and angle 2, are not adjacent angles. Do they have a common vertex? No. The vertex of this angle is here. The vertex of this angle is here. They have to have a common vertex. So they have to be side by side, but they also have to have a common vertex. And they have to have a common side. Notice angles 1 and 2 have a common vertex, and they share this ray as a common side. The third thing is they cannot be overlapping each other. And what that means is they can't have any common interior points. So if I were to pick a point in angle 1 inside of it, are those points in angle 2? No. So these are adjacent because none of their points overlap. The difference would be if I were to draw a big picture here, angles 1, angle 2, and then this great big angle 3. Are angles 1 and angle 3, are they adjacent? No. They have a common vertex, and they have a common side. This is the side for angle 1. It's also a side for angle 3. But if I pick points inside angle 1, are they also inside angle 3? Yes. And so those are overlapping angles, not adjacent angles. Does that make sense? So adjacent, just side by side, they can't share any common points. Okay. Linear pair. First of all, what's a pair? 2. So a linear pair is only 2. It cannot be more than 2. What word do you see in the word linear? Line. So basically a linear pair is a pair of angles that form a line. When you look at the picture, do you agree that angles 3 and 4, when they're put together, form a straight line? Okay, and there's only 2 of them, right? Not only do they have to form a straight line, but they do have to be adjacent. If they are a linear pair, they are also adjacent angles. Would you agree that 3 and 4 are adjacent angles? They're side by side. They have a common vertex. They have a common side. Points in 3 are not in 4. Okay, but it's a pair, only a pair. So look at this picture. Would angles 1 and 3 be a linear pair? Would angles 1 and 3 in this picture be a linear pair? Think about it. They have to be adjacent, and there can only be two that make the straight line. If I were to redraw angle 1 and then redraw angle 3, do they fit the characteristics for adjacent angles? Do they have a common vertex? Yes. Do they have a common side? No. If I were to draw the two sides of angle 1, are either one of those the sides for angle 3? No. The angle 3 sides are in blue. The angle 1 sides are in red. They do not have a common side. There is a big gap in between them right here. If they're adjacent, they have to be touching on one side. So these are not a linear pair because they are not adjacent. It takes this middle angle's value to add with it in order to be 180 degrees a straight line. So this is not a linear pair. Two angles that together form a straight line. Does that make sense? Okay, we're going to see how well it makes sense on this next part. Okay, so there's going to be several examples in your notes. We're going to go through them together. You're going to look at these two angles in the picture and you're going to answer the question. Are these only adjacent, adjacent and form a linear pair, or not adjacent at all? Okay, only adjacent, adjacent and they form a linear pair, or they're not adjacent at all. So I'm going to give you about 30 seconds, look at those two angles, and then we're going to, as a class, answer the question. Okay, hands up if you think they are just adjacent. Okay, hands up if you think they're adjacent and they form a linear pair. Okay, hands down, hands up if you think they're not adjacent at all. Okay, what I usually find helps for students is if you'll redraw those two angles away from the picture. So draw AEB, I'm going to redraw it down below. AEB, here's AEB, and then I'm going to draw BED. So BED. Now look at the two angles. Are they touching, sharing a common side, sharing a common vertex? They are adjacent. Do they form a straight line? Yes. What confuses some people is this ray EC that's in the picture. We're not using that for this question. This question is just about angles AEB and BED. So the answer should have been adjacent and form a linear pair. Okay, let's try another one. Again, I'm going to give you about 30 seconds. Flip your notes over, look at this one, and decide which one you think it is. If it helps you, redraw them. You're looking at AEB and BEC. Hands up if you think they are only adjacent. Okay, hands down. Hands up if you think they're adjacent and they form a linear pair. Hands down. Hands up if you think they're not adjacent at all. Okay, we've still got a few people that disagreed. So again, I'm going to redraw it. AEB is this angle right here, so I'm going to redraw it down here. And then BEC. BEC is this angle right here, so I'm going to redraw it down here. Now look at those two angles. Do they have a common vertex? Do they have a common side? Are they adjacent? Yes. Look at the angle that's formed. Does it form a straight line? Does not form a straight line. A straight line would have to go like this with opposite rays. This one is going to the left and this one's going up and to the right. They do not make a straight line, just these two angles, because we didn't use this part over here. So it is only adjacent. Your picture has to result in a straight line for it to be a linear pair. Okay, let's try one more. Again, about 30 seconds. DEC and AEB. Okay, raise your hand if you think they are only adjacent. Raise your hand if you think they're adjacent and they form a linear pair. Okay, raise your hand if you think that they are not adjacent at all. Okay, we still have a few disagreements there. So again, redraw the picture if you need to. DEC is referring to this angle right here. So I'm going to redraw DEC. AEB is referring to this angle right here. So now I'm going to redraw AEB. So to be a linear pair, remember they have to be adjacent. Are those two angles, the red and the blue, adjacent? No, they have a common vertex, but they're not sharing a common side. They are not right next to each other. So if they're not adjacent, they cannot form a linear pair because they have to be adjacent to form a linear pair. So it is not adjacent. Okay, very important that you understand the definition of adjacent and linear pair. A linear pair is a straight line. What did we say that a straight angle always measures? 180. So anytime you see a straight line, remember that all of the angles in the picture then should add to be 180. So when you look at a linear pair, you should know that that means that those two angles are going to add to be 180 because it's forming a straight line. Okay, I'm going to skip this part for just a minute. I want to go ahead and go to the end of the notes because we probably won't have time to finish all of it. And I want to talk about vertical angles first. So if you will find the part that talks about vertical angles in your notes, I'm trying to get there, but I get impatient and I end up pressing my arrow button too many times. Oops, I think I accidentally got to the next set of notes on accident. Yeah, okay. No. I'm going to skip this one for now. Okay, so find where it says vertical angles. Is everybody with me? Found vertical angles? Okay, so the next definition we're going to talk about is vertical angles, and this one is super important. You will use vertical angles forever in this class. Often, it's going to pop up all year long, vertical angles. I don't count off for spelling in this class. It's not going to let me write because I hit the wrong slide. But in pre-AP, I do. But I will point out a lot of students misspell vertical. They misspell it. So vertical is C-A-L. It's vertical, not vertical C-L-E. So make sure you write that correctly. Okay, vertical angles are going to be two angles that are formed by intersecting lines, and they are the angles that are across from each other. They are not the adjacent angles. So notice it says not adjacent, and they are formed by two intersecting lines. So when you look at this picture, and I'll draw it over here on the board as well, which angles in the picture are going to be vertical? So if this is my picture up here, 1, 2, 3, 4, which angles are vertical? 1 and 3. So on your picture, you can mark angle 1 and angle 3 are going to be vertical. Which other angles are going to be vertical? 2 and 4. They're the ones that are across from each other if two lines intersect. Okay? Now, they don't put this in the notes in this section, but they make you use it in this section on the homework. So you're going to have to add our very first theorem to your notes. We're going to learn a lot of theorems. The difference between a theorem and a postulate. A postulate we learned is kind of common sense. It's things that we believe to be true, but they're not proven true. Like, through any 2 points, there is exactly one line. A theorem, on the other hand, is proven true. There is a mathematical proof that a mathematician has written that proves that the concept is true. And this is our very first one. So on your notes, add this theorem. It's called the vertical angle theorem. And you're going to need to memorize that because we'll use it in our proofs later on. Vertical angle theorem simply says vertical angles are congruent. And you can use a little congruent symbol for congruent if you don't want to write out the word congruent. And you can use that anytime in place of the word congruent. What does it mean if they're congruent? Equal. Same measure, right? So that means if angle 1 is 30 degrees, what's the measure of angle 3? 30 degrees. Now, what do you notice about angles 3 and 4 when you put them together? Okay, they're not going to be the same, but what do you know about them? Say it again. They're a linear pair. They form a straight line. Would you agree that angles 3 and 4 are adjacent and form a straight line? So what is a straight line always going to equal? 180. So if this one's 30, what does this one have to be so that they form a straight line? 150. And if this is 150, what does angle 2 have to be? 150. And so that's information that you'll be using on some of your homework when you're trying to figure out different angle measures, okay? So vertical angles are congruent and they're across from each other if two lines intersect. Last example that you'll see in your notes here is naming the vertical angle pairs. And this is the last part we'll do today, and we'll save the complementary and supplementary for Thursday. So name the pairs of vertical angles. Let's see how we're doing with naming angles. First question I have for you is, can I name any of those angles angle M? No, because there's lots of angles in that picture. Okay, so somebody name for me one angle in the picture that you see that would have a vertical angle. Any angle that you see. Say it again, Barrett. Angle JMH, okay? JMH. So you're referring to this angle up here, JMH. Which angle is vertical to it? Good. I heard two different ways, and both ways were correct. Angle LMK or KML. It doesn't matter as long as M is in the middle. Does everybody agree that the top and bottom angles are vertical? Okay, so it said name the pairs of vertical angles. This would be one pair, but there's another pair. Jacob? Angle JMK, and what is vertical to it, Jacob? Very good. Angle HML. So left angle and right angle. Are we all clear on vertical angles? All right, so we have about 5 minutes. I'm going to go ahead and pass out this assignment slip, and that way we're clear on what we're supposed to do, and you can write on it. Once everybody gets it, I'll make sure that you're all understanding. Oops, I think I didn't count right there, Carlos. I think you need one more, right, Brian? Yeah, sorry. Okay, so at the top of this blue slip, if I were you, I would write due. When is this going to be due? Monday. Due Monday. However, there are some things that you have learned that you could go ahead and start on textbook page 32. We have not done the next section, so I wouldn't even worry about textbook page 38. Okay, right now. But if you want to go ahead and get a start on the things we learned today, look for anything that deals with vertical or adjacent or linear pair. If it says complementary and supplementary, we didn't talk about that yet, so you may not know what to do, and that's okay. Don't worry about it. Are we all clear what to do? Assignment 2 is due on Thursday. We will take a quiz on Thursday, but we will take it after we go over complementary and supplementary. So we'll start class and then we'll separate and take a short quiz. This first quiz is just to see how well you're doing with the concept. So don't stress about it. Study, make sure you're ready for it, but don't get anxiety about it, okay? Because it's not that big a deal.